Question 8. This question is of arithmetic progression and geometric progression. A progression has first term a and second term a square over a plus 2. First term of the progression is a and the second term is a square over a plus 2, where a is a positive constant. For the case where the progression is geometric and the sum to infinity is 264, find the value of a. Now in this part a, the progression is geometric. Simply we can write GP, geometric progression. First term is a, second term is a square over a plus 2, and sum to infinity is given, that is 264. So we can write that S infinity is equal to 264. First term of the geometric progression is a, second term is a square over a plus 2. So we will find the common ratio. Common ratio will be second term divided by first term. This is the first term, this is the second term. If we divide second term by first term, we get common ratio, that is represented by R. So R is equal to second term divided by first term, that is A. So we can write R is equal to A square over A plus 2 multiplied by 1 over A. Cancellation. We get R is equal to A over A plus 2. R is equal to A over A plus 2. Now S infinity is, a formula for S infinity is sum of infinite terms. Formula is A over 1 minus R. In this formula, A is the first term which is given, that is A, and R is common ratio. We have just found A over A plus 2, that this is R. Putting here the value, S infinity is given, that is 264. So we can put here the values of S infinity, A and R. First of all, S infinity, we will write A, first term is A over 1 minus R. R is A over A plus 2. So simplifying the denominator by taking LCM, we can write S infinity is equal to A over A plus 2 minus A over A plus 2. This becomes, this is cancel out. A plus 2 will be multiplied by A So this becomes S infinity will become A into A plus 2 over 2. This is S infinity, but S infinity is given, that is 264. We are putting here the value of S infinity. This becomes 264 is equal to A into A plus 2 over 2. By cross multiplying, A square plus 2A is equal to 528, because this 2 will be multiplied by 264, it becomes to 528. Now writing it in standard form, A square plus 2A minus 528 is equal to 0. This is a quadratic equation. From here we get two values of A by using quadratic formula here, or factorizing, or use a calculator. By calculator we can get these two values. A is equal to 22 or A is equal to negative 24, but this is not valid because it is given in the question statement that A is a positive constant, so we are taking only the positive value of A, which is 22. So only the answer is 22. This is not valid. Part B of this question is, for the case where progression is arithmetic and A is equal to 6, determine the least value of n required for the sum of first n terms to be less than minus 480. Now in this part B, the progression is arithmetic and the value of A is given, that is 6. Sum of n terms to be less than minus 480. So first of all, we know that uh, it is given that A is equal to 6. This is first term, A is equal to 6. Sum of n terms to be less than minus 480. It is given sum of n terms is less than minus 480. Now the formula of sum of n terms in arithmetic progression, formula for sum of n terms will be n over 2 into 2a plus n minus 1 into d less than minus 480. We have to find the least value of n. Now putting the value of a, that is 6, this becomes a n over 2, 2 into value of a is 6 plus n minus 1 into d less than minus 480. Now we need d, that is common difference. D is common difference in this formula. So first of all we will find the value of d. Now this is an AP, arithmetic progression. Now it is given that first term is a and second term is a square over a plus 2. So we can write in AP, first term is A and second term is A square over A plus 2. Now putting the value of A which is given, that is 6, we get this A is equal to 6. This become first term will be 6, second term will be 6 square 36 over A plus 2, 6 plus 2 that is 8. Simplifying it, we get first term is 6, second term is 9 over 2. So this is the first term, this is the second term. Common difference we need. Common difference here, we represent this inequality by A for reference. Now in this inequality, we will put the value of D. We will find value of D. This is the first term in AP. 9 over 2 is the second term. So common difference, first we find common difference. D is equal to 9 over 2 minus 6. We get D is equal to minus 3 over 2. Now putting this value of D in this inequality which is represented by A, we are putting this value of D here. This becomes from equation A n over 2 12 plus n minus 1. The value of D is negative 3 over 2 less than negative 480. Now we will find the value of n. Simplifying it, n over 2 12 minus 3. This minus 3 over 2 will be multiplied by n and minus 1. It becomes 12 minus 3 over 2n plus 3 over 2 less than negative 480. Simplifying, now we add 12 and 3 over 2. This become n over 2 27 over 2 minus 3 over 2n less than negative 480. Further simplifying, 27 n over 2 minus 3 over 4 n square. We are multiplying this n by 2 by the terms which are inside the bracket. Minus 3 over 4 n square is less than minus 480. Now we will multiply the whole on both sides of this inequality by 4. This is not 2 but this is 4. 27 n over 4 minus 3 over 4 n square minus 3 over 4 n square is less than negative 480. Multiplying each side of the inequality by 4. To remove the denominator, this becomes 27 n minus 3n square is less than 4 minus 480 multiplied by 4, that is minus 1920. Now it can be written as 3n square minus 27 n minus 1920 is greater than 0. Now factorizing, now we can use a quadratic formula here. We get two values of, we can use here a quadratic formula or calculator. We can get two values of n. N is 30 point, n is, this is an equality, we can write that n is greater than 30.195 or n is greater than negative to 21.195. So this is not applicable because n cannot be negative. This is not applicable. So only we will use this value n is greater than 30.195. Greater than what we will give the answer in integral form. N is greater than 30.195. There are very many values greater than 30.195. For example, 30 greater than 30.195, 31, 32, 33, and so on. But least value is 31. So least value of n, that is equal to 31. This is the answer.